On to topic 2 of chapter 8. Here we're going to work on the quadratic formula and solving using the quadratic formula and approximating solutions. Now, what we just did before in topic 1 was completing the square. And if we have a quadratic equation in this form, and we move the c term over to this side, and then take half of the b term, and then complete the square and get the binomial squared of what we just did. And interestingly, this is in our textbook. And I should actually show you that. I've gone into the textbook here, and this is right from your textbook. So there is the standard form of the quadratic equation in which we've taken the c term to the other side. Now we're going to divide by a over here, and we're going to take half of b and square it and add that to both sides. Then factor this into its binomial squared equals that, and we have common denominators here. We had to do that, and we have this. Now we take the square root of this side plus or minus the square root of that side. Notice this is a perfect square, and it comes out to this. Then, and these are the same, so we now add a negative b over 2a to both sides, and then just put it all over 2a, which is our common denominator. And this here, by using the process of completing the square, is what we call the quadratic formula. Wow. And that's what we're using in section 2. So, they're going to give us some examples in our PowerPoint slides. I'm not sure it's the same one, but we can look at this one while we're here. In order to use the quadratic formula, it has to be in standard form, and then we identify the a term, which is 5, the b term, which is 8, and the c term, which is 3, and we're going to substitute that into our quadratic formula. Now, again, reading the textbook's a good idea. And we're back to our PowerPoint slides, but this is how they do it. There's the quadratic formula in standard form. They're going to solve for x. Now, I recall in one course I took or taught, the students had to learn this. How do you derive it? I showed it to you in the textbook. We don't require that here. But there's the quadratic formula. And remember, a cannot be 0 because dividing by 0 here would make this an imaginary number, or undefined number, I should say. Not imaginary, undefined, yes. Okay, so this is very similar to what they had. So let's do this for you step by step. And step 1 is to put it in standard form. And you might say, why do you have to do that? Well, because it has to be in standard form. So you can pick out what A is. That's A. what B is and what C is. Now the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we just substitute. Now b is a positive 5, so this becomes a negative 5 in the formula. Because of the negative there, it's a negative of a positive 5 is a negative 5. Plus or minus the square root of, now b is always going to end up positive because we're squaring it. So it's going to be 5 squared minus 4 is in the formula. A we said was 3. And C is a negative 2. And that's all going to be over 2 times 3, which will be 6. Okay. Now, x equals negative 5 plus or minus the square root of 5 squared is 25. Now, this is going to be a negative 12 times a negative 2. So that's going to be a positive 24 all over 6. Now we get x equals negative 5 plus or minus the square root of, that looks like a 49. Ooh, that's going to come out as a perfect square there. All over 6. Well, this then becomes a negative 5 plus or minus 7, which is what the square root of 49 is, all over 6. So let's put them over here. X will equal minus 5 minus 7 is a minus 12, divided by 6 is going to be a negative 2, or x will equal a negative 5 plus 7, that's going to be a positive 2 over 6, which is a positive 1/3. And this was a negative 2. Double checking that. Yeah, negative 12 divided by 6 is a negative 2. This is going to be a positive 2 over 6 is a positive 1/3. Okay, now interestingly, let's do this another way here. I have this up here. I could have actually factored that. Anytime you get whole numbers without a radical, that could factor. So this is going to be 3x. This is going to be x. This is going to be a 2 and a 1. And my signs are going to be a plus here and a minus there. So this is going to be 3x minus 1 equals 0, or x plus 2 equals 0. And then this will become a 1 divided by 3. There's my 1/3. And this becomes an x minus 2. Okay, so we saw that if we use the quadratic formula, we did all of this substitution, it would end up giving me these two answers. We also knew if we used factoring, which is the first technique we use to solve quadratic equations, equations to the second degree, that would work. But again, if it didn't factor, we might try completing the square, which I wouldn't use for this because of the 3 there. Or we could use the quadratic formula. Okay, let's see it now. All right, we had to determine what A, B, and C was by putting it in standard form. We did our substitution. We got 49 under the radical, which was 7. And we did both of those. And we got that, which is that. And again, we also did the solution of x by factoring. And here's what they're telling us. Okay, a little summary here. To solve a quadratic equation, one method would be to put it in this form. We could divide both sides and take the square root of both sides. Okay. If this doesn't apply very readily, we could then write the equation in standard form and factor it using the principle of zero products, which is what I just illustrated. And then, if the factoring seems difficult or impossible, we can always use the quadratic formula. We could also use completing the square. Again, it depends on the equation. And these are quadratic functions. And let's solve this one now using the quadratic formula. Okay. So for this one, what we'll do is also show you how to do it doing completing the square. So we write the equation in standard form. Now for completing the square, we bring the c term over as a negative 7. We bring the rest of it over here, x squared minus 2x. Now we are going to put a set of parentheses in which we put our x there. We put our half of b term, which is a negative 1. Now we're going to square this to give our new c term, which is what we'll add to both sides. Then we get x minus 2. Well, let's do that correctly here. Equals negative 6. Now we take the square root of both sides, plus or minus, and I get x minus 1 equals plus or minus I, the square root of 6. Then I bring my negative 1 over as a positive 1 plus I, plus or minus I, the square root of 6. Okay, so that's completing the square right there, and these are our answers. Now let's use the quadratic formula. So my A is 1, my B is a negative 2, and my C is a 6. So I'm going to write the quadratic formula. X equals negative b. So this will become a positive 2 here. Plus or minus the square root of, now b squared is going to be 4 minus 4 times, I'll write it out here, 4 times 1 times c, which is 7, all over 2a. So x equals 2 plus or minus. Now, this is going to be a negative 28, plus 4 will be a negative 24, all over 2. Now, I should show you that a square root of a negative 24 will become I, the square root of 4 times the square root of 6. Teasing this apart. So this will become then x equals 2 plus or minus 2i, the square root of 6. This is going to become a 2, and my 2i, the square root of 6. Now all of this is going to be over 2, and I separated that so I can do the canceling. This is going to become a 1. This is going to become plus or minus. Now my 2's cancel out. I, the square root of 6. And you'll notice that's what I have here. So whether I do it by completing the square, which is what I've done here, or by the quadratic formula, which is what I've done there, the answers come out the same. This would not factor in any regular form. Okay, let's take a look at it. So they're identifying, after they put it in standard form, the A, B, and C. They're substituting and eventually get this. Now notice you can put the 2 over the 2. That's going to be a 1, and this is going to be a 1. And there we get our answer. Now notice how they're writing this. They're writing this in complex form, a plus bi. The I is not under the radical. Theoretically, having the I there would be okay, but it's not quite in standard form. And again, depending on what your instructor would ask you to do. Now for approximating, and we'll be using this in some applications in our next section, we put this into a calculator, and the key to do that is to put this in a parenthesis, and then eventually you're going to divide by 3. But by putting this in the parenthesis, we get one value that we're going to divide by 3. If you do 2 plus the 31, then divide by 3, it's only going to do this by 3. But by having it in a parenthesis, and that's what that grouping symbol, that division bar, indicates, that's how you put it into your calculator. And you can, try some of these to be sure you're getting it done correctly. And this would be the positive value. And if there's a negative, you would get a negative value as well. Okay, that'll wind up this section.